Is there anything that you want me to explain in there? Anything you want me to explain in there? Okay. Explain number 3. That's called the associative property. Okay, so it's like this. What do I want? I want that. Let me get a blank document.
You do right, create or tap.
Wow, where? Oh, there. Thank you. Okay, awesome. Shut up. That's bad. Okay. Number 3, right? Okay, so the rule number 3 is CD. Do you guys notice about the scalars and the matrix? How do you see the differences? What are the differences there? Who's that? Nice, good job. What's lowercase? Yeah. That's right. Scalars are lowercase, matrices are uppercase. Okay? So this is property 3, and they call it the associative property. It's equivalent to, in scalar land, it's equivalent to saying right? Same thing. It's saying, so supposing this was 2 and this was 3, and this was a matrix 1, 2, 3, 4, then what you can do is you can leave the 2 outside and multiply and do this multiplication first. Okay, so that would give you 3, 6, 9, 12, and then you can do the following multiplication. Okay, that's all it's saying. All right. Okay, matrix multiplication. So take this down and then I'll give you how it's done, okay? All right, so let's start out with you guys telling me what the order of the first matrix is. What's the order of this matrix? 3 by 2. Okay, it's the number of rows by number of columns. It's 3 by 2. What about the order of this matrix? 2 by 3. So this stuff that's here in red, all it's saying is that these two numbers have to be the same. Okay, if they are not the same, the multiplication cannot happen. Okay? And then the result of that multiplication is going to be another matrix, and the order of that matrix is the same as if you are to cancel these 2 out. So in this case, your new matrix is going to be a 3 by 3 matrix, which is right there. That's a 3 by 3 matrix. All right, you guys understand the first requirement for matrix multiplication. Okay, the number of columns of the first is got to be equal to the number of rows of the second. Okay, if that is not true, then you can't even do the multiplication. It doesn't even exist. Okay, and then the result is going to be the outside 2 terms. Okay, so let's say you want to find this element here. Okay, what row is it in? First row. So in the first matrix, you will go along the first row, and I'll explain to you what I mean by go along. Okay, what column is it in? First as well. So then in the second matrix, you're going to go along the second, oops, my bad. First column, right? Right? This element is in the first row, first column. So you're going to go first row, first column. What do I mean by go? This is what I mean, okay? You take this and you times it by that. What do you get?
3.
So 1 times 3 plus you take this and times it by that. What's your answer? 3. That is how you get 3 in here. You may do one more so you can finish this off on your own then? Do one more term? Yeah? Okay, I need to erase a lot of the stuff, so. Okay, so let's say I want this term here. What row is it in? Third row. So in the first matrix, you're going to go, actually, you know what? Let me pick another term. I'll pick this guy here. Okay, what row is it in? Second, so you're going to go along this row. What column is it in? Third column, so you're going to go down this column. What I mean by that is you're going to take minus 2 and times it by 1. So you get minus 2 times 1 plus, then you're going to take 3 and times it by 6. And what do you get? 16. Can you fill in the rest of the elements of the matrix? This one here? No, so first you ask yourself, what row is this in? Second row. So you're going to go in the second row. Which column is it in? Which column is it in? Sorry? Second one, so it's going to be this column. All right? So can you finish this matrix up, please? Properties of matrix multiplication on page 574. And notice this really important statement here, okay? Do not commute under multiplication. And I'll explain that to you in a minute. So get that down. And take a look at page 574 to get the properties of multiplication of matrices. 574? Not the right page? Uh, 533, indeed. Thank you. Okay? And I'll explain to you what it means to say that matrices do not commute, okay? In other words, you know how in scalars 3 times 2 is 2 times 3? Right? Always? Well, with matrices, A times B is not necessarily always equal to B times A. Okay? You can't flip the order of the multiplication. And we'll see that in a minute. What I want to do now is do n-box stuff. Oh no, my God, still more stuff. A very important matrix called an identity matrix. Okay? Called an identity matrix. It's equivalent to the number 1 in scalar land. Okay? It's equivalent to the number 1 in scalar land. So an identity matrix, first of all, has got to be square, which means that it's got to have the same number of rows as columns. Okay? It's got 1 on the main diagonals. So what I mean by that is that this is the main diagonal here. It's got 1s on it, and everywhere else it's a 0. Everywhere else is 0.